All right. Hello, everyone. As you might see, this is design how your objects talk through mocking talk. And I wanted to start it with one very interesting and exciting quote, which kind of outlines what this talk is about. One of the most common mistakes people make is to fixate on the goal or expected outcome while ignoring their underlying behaviors. So this quote is from a company called Reverse Focus. And Reverse Focus is one of the biggest companies specializing in reverse mortgages. So it's not a quote on software engineering, it's indeed a quote on reverse mortgages. Reverse mortgage is a home loan providing cash payments based on your home equity. Homeowners normally defer payments of the loan until they die or move to another house or maybe buy a new one. And those guys that are professionals or specialists in this area discovered that people tend to not focus much on what they do and how they will get till the final goal. They focus more on what this final goal is. So when you're taking the mortgage, most of the people, what they do is they think, oh, in 10 years I will be able to return this mortgage. What they don't think about is what kind of behaviors they will do in those 10 years. They don't think that in 9 months they will probably have a kid. They don't think that maybe they will want to change a job multiple times in those 10 years. So people completely ignore underlying behaviors. And this will be an underlying topic, final goal or outcome versus the behavior throughout this talk today. So who am I? I'm Konstantin, also known as @everzet, almost everywhere. I'm BDD practice manager in a company called Invika. This is a UK-based company. We do PHP open source enterprise software, everything related to PHP, any kind of frameworks. And we specialize in high-level enterprise solutions with really complex architectures. I'm a software engineer. Recently, in the last, I would say, 2-3 years, I've been moving more towards business. In regards of business communications, agile planning, and now I'm somewhere in between software engineering and business. During the different phases of my life, I created different tools for PHP, especially like testing tools like Behat, Mink, Prophecy, PHP Spec 2. During different phases of my life, I also contributed to frameworks like Symfony, Doctrine, and Composer. So what is this talk about? This talk about multiple things. It is essentially about test-driven development with and without test doubles. So I will introduce you slowly into test-driven development, and then we'll start ramping up, discovering different approaches to test-driven development, looking at tests differently than you might looked at them before. We will introduce and try to make sense out of different types of test doubles. We will explore object-oriented programming as a messaging paradigm. And we will look at software design as a response to message observations. And this talk will have a lot of code examples. Some of them will be moderately complex. I tried to remove complexity from them, but keeping the message in them. It's, as you could imagine, really hard to show something very simple and at the same time present some design concepts. So some of the examples will be on the edge, so just bear with them. Okay? So it all officially started with this book, Test-Driven Development by Example by Kent Beck, somewhere in 2002. Kent Beck started to experiment with test-driven development long before, but he finalized his experiments and thoughts into this book. And if you look into this book, you will find some overly simplistic examples like this one, right? So the idea with test-driven development is you start you start development of the system from usage of the system, right? You're defining how you will use the system when it's done, before it's done. And as many other examples in many other software design books, this is a Java, right? I know this is a PHP conference, I translated it. So what do we do here? Well, basically we're testing that you can do multiplication based on the name of the method with dollars. So we create new instance of $5. We do 5 times 2, and we check that the product of this is actually 10. And then we do the same thing times 3, and we check that the product of this is 15, right? So this is very simplistic way to define TDD, and we know that most of our actual real-world applications don't look like that, right? They're much more complicated. So our applications and our tests, our test-driven approach will look something like this. So in this case, we have this system called user manager, or object called user manager, which is dependent on event dispatcher and user repository. And what it does register the user, but in addition to that, it should dispatch user is register event. This particular tests that this event, user is registered, is indeed dispatched. So how do we do it? We register new listener, which is a closure here, and we increase the closed up variable to 1. And then the key of this test, as any other classical test-driven development test, is this bit, right? The last statement is what's called state assertion in test-driven development. We assert that the resulting state of the system is indeed what we expect it to be. If you think about it, doing stuff, setting up the system, and then at the very end, asserting that the system at the end is in the predicted state. This is a very specific way to look at our systems, at our applications that we develop. It's like our application is the way to get us from point A to point B, and we don't care what we did there internally, right? We don't care how we got to this point B. What is important that we got there. Now, what if things that happen between you getting from point A to point B is important? What if there is millions of ways to get from point A to point B? And what if all those different ways are important for your system? What if those ways are actually influence your design? What if they define design of your system? Back in 80s or 90s, there was a big movement in psychology and in literature societies where people were moving towards ideas that life is a journey, not a destination. What we do throughout our lives as human beings is more important than where we're getting with that, right? So the things that we do throughout our life is more important where we end up with that. And this is really complex life principles. But what if those complex life principles are actually applicable to software design? What if the idea that life is a journey, not a destination, is actually applicable to the way we design our software? As a matter of fact, as with anything in software industry, I'm not the first person to come up with these ideas. And back in 2009, a couple of people from London Agile Society or Extreme Programming Group came up with this book. So this is Growing Object-Oriented Software Guided by Tests book, and it's the second most important book if you want to do test-driven development. So what does it do? It flips things upside down. It says communication or behavior of things internally are more important than the outcome of those things. So let's look at our test again. Let's look at things that will communicate between each other. So we at least have 2 collaborators. Collaborators are the guy that our system will talk with, and 1 object we're interested in. So we have user manager, event dispatcher, and user repository. Now here's the tricky bit. Find a message. So find the communication between those guys. Where do they talk? Well, you can't see that because it doesn't happen in test. If you look at the source code, it doesn't happen in source code either. It happens in the runtime when you actually execute application. Well, you might think, this is still a good test, right? And I wouldn't argue with that. But if it's so hard to see the message, is it really that important, right? Maybe state is what's important for the software. We know that object-oriented programming is not really about messages, right? They are about important things like classes, methods, encapsulation, inheritance, right? That's what OOP is all about. It's about hiding things inside. Well, father of OOP wouldn't agree with you if you think this way. Alan Kay is the guy that coined the term object-oriented programming, and that's what he has to say about what OOP actually means. OOP to me means only messaging, local retention and protection and hiding of state process. Not only like valuing messaging over state, it's actually about hiding state as much as you can. So if messaging is that important, how can we expose it? Well, in most languages, especially in PHP, we have this thing called interfaces, right? They do kind of expose messages. They do expose topics that we can talk about. Well, the problem is they do not expose communications. It's like interfaces are topics you can talk about. But in order to define how those topics are used, how you build those conversations, you need something more. And those people that created Goosebook come up with this idea of test doubles. And test double is the way to expose communication between objects dynamic by nature in the static form. And this way is doubles. So now we'll talk a little bit about test doubles. There are 5 known types or commonly recognized types of test doubles. There is a dummy, there is stub, spy, mock, and fake. I will go through each one of those, providing you a very simple example, and hopefully this will make a lot of sense to you. And they're not that complex. That's the message that I want you to take away from that. For examples today, we will use this library, Prophecy. This is my mocking library. The reason why we're using it is not because you can't use any other library. You can use mockery really easy. But this one makes it very, very easy to write really concise and short examples. So that's why we'll use it today. So the first 2 things we do, we import namespaces that we'll use. Prophecy has this thing where it kind of creates domain-specific language to describe how things will happen. And Prophecy kind of describes objects in the future. So the way it handles it, it kind of creates prophecies for your objects. And those prophecies has predictions and promises. So in order to create prophecy for the object, you have this object called Prophet. You ask Prophet to prophesize specific interface or the class name, and it returns you the object prophecy. On the object prophecy, you can say, change name, this is actual method call, with this argument, should be called in the future. Then you get the actual object. This one is a controller, this is a prophecy, this is an actual user object. We call the method, and then we check predictions. Check predictions actually checks that this should be called was indeed called. Okay? So let's start introducing different types of test doubles. So let's say dummy. So we have this very simplistic system, which is dependent on authorizer. And depending on the things that you do with the system, it will also increase the login count, right? So it is responsible for authorizing users and increasing the login count as soon as you have new authorized user. So let's say we want to test that newly created system has no logged in users. Right? So we kind of want to check that when you create the system object, the get login count will return 0. But we don't care about this authorizer object, because we know that in this particular case, we would never call it. But we still need to pass it because it is a constructor argument. So what happens there is we create a dummy. Dummy is the very simplistic type of test double. It's a test double that you don't care about. You just create it to fulfill the type hint expectation, right? You don't care what happens with it, and people can call methods in it. It will just always return no, and there is no expectations in it. So dummy in a very simplistic form is a test double that you don't care about. And then every single consequent test double is the one that you care a little bit more about. So stub is the one that you care a little bit more about. So we have our system, and now we have a login method. And what login does, depending on authorize call return, if it returns true, and it increases login count. If it returns false, it doesn't do anything. So let's say we want to write a test for successfully authenticated users, right? We want to test that counts successfully authorized logins. So the way we do this is we again prophesize the authorizer class. We pass it as a constructor argument, but then we do this thing. We say out, which is our authorizer, authorize with those arguments will always return true. This is a stub. So stub says, I don't care if this method is called, but when it is called and if it is called, I will always return this thing, right? Stub doesn't care if you call the method or not. But if you do, it will always behave in a very predicted way. So as you can imagine, the next type of the double is the one where you do care about it being called. So let's say we have another additional functionality inside our login. So in addition to increasing login count, we actually also call this object called login timer, and we record login for this username, right? So in this case, we will have additional login timer prophecy, and then we will say, after we made a call, timer record login with this argument should have been called. That's what SPY does. SPY records every single call you do on the object, and then you can make assertions on it. You can say, this method should have been called previously. Mock is just a different permutation of the SPY. Mock is a delayed SPY. So this is how SPY looks like. You make a call, and then you say, timer record login with this argument should have been called previously. The way you structure this with mock is you say, before doing a call, you say timer record login should be called in the future, and then you make a call, and then you do this get profit check predictions. So you check that your predictions work. And finally, the last type of test doubles is fake. So fakes are really, really simple test doubles. You never use mocking libraries to define fakes because fakes are simplistic actual implementations of your classes, right? So if you want fake, you just create fake implementation manually for the specific interface. A good example of fake implementation is like file system repositories if you're using Doctrine, or in-memory collections, or in-memory APIs, these things, right? Does it make sense for everyone? Cool. So test doubles are really interesting because people tend to think about them as a way to isolate things. And the funny thing about that is, even though 70% of developers think about test doubles as a way to isolate you from the system, make your tests really fast, that wasn't been intention of creators of test doubles. So one of the guys that created test doubles have this quote to say. At the time, we were struggling to promote the idea of using mock objects as a design tool. Mock objects were created as a way to design your system, not to isolate it. Many people saw it only as a tool for speeding up unit tests. Right? That is a problem. So people have misconception of what test doubles actually are, and they use it for purposes where test doubles are not really good at. And that's why we have a lot of problems with test doubles. So going back to our example, we still have our dispatcher and repository and user manager guy. How do we refactor this thing in order to use prophecy and actually expose communication between objects? Well, very simple, like this. Right? So the way it works now is we pass event dispatcher class into the constructor of user manager, and then after we made our calls, we do dispatcher dispatch with these arguments should have been called previously. We exposed communication. Now we care that this communication happened, and we care that this communication happened in this particular format while we call these things. All right? So I know this talk is called Design How Your Objects Communicate, and I didn't talk much about design till this point. And you might ask me, what does this all has to do with design? Like, you basically exposed some kind of implementation detail in your tests, and how do you think it will help with tests? Well, the idea behind Goosebook is based on this very simple premise. The act of observing will influence phenomenon being observed. So the idea is, by exposing communications, you can fix communications problem because they become apparent. And I will prove it to you by going through 5 different examples of tests and the underlying systems that we're testing, and showing you how exposing communications in those systems help you to find problems, identify those, and simplify both your code and tests using mocks. So let's go into the first example. So the first example is very simple MVC controller. I will use Symfony, but it will probably look the same in any other framework. So what do we do here? We are showing the list of packages for a specific maintainer. So we have doctrine, we get it from container, we get repository, then we get filtered query builder for this specific maintainer. We order by name, we get query, and we execute it. And then we also render the template. All right? Looks very simple, right? You can read it, you can do something with it, and it takes only how much? Like 10 lines of code? It's very, very simple action. Well, that is until you start actually writing tests for this thing using mocks. And then it will look like this. Right? So there's two options you can do here. You can get horrified and decide that that's why I'm not testing controllers. That's probably why everyone in Symfony community is so scared of like unit testing controllers, and that's why we're functionally test them, right? Close this thing forever and don't never write unit tests anymore. Or you can look deeply and start analyzing this test. Because with mocks, there is an interesting pattern where every time tests starts being smelly or starts being really, really verbose, they are telling you something. And in this particular case, they tell us, first of all, that we have 10 different collaborators. So when you're calling this one particular method on your controller, one particular action, it actually talks with 10 different objects inside your system, right? Not only that, it also sends 7 different messages to one of those 10 guys. And this is a problem. And the problem is, every time you would want to change one of those 10 guys, every single action in every single controller will need to be changed together with it, right? So this problem in software engineering is called single responsibility principle violation. Single responsibility states that every class should have a single responsibility. All its services should be narrowly aligned with that single responsibility, right? And single responsibility for controller is to get request, pass things to the services layer, and then based on what services layer tell, create a response. And I'm not saying that this method is bad. This is a very valid way to develop software. But what I'm trying to say is by looking at your tests, by trying to analyze what your tests are telling you, and by trying to simplify those tests, you can actually simplify this controller action. So how would we approach this? So let's say we want to rewrite this test that we have previously, taking into account that we want to minimize the amount of collaborators and amount of messages that we're sending to them. So how would it look like? Well, I can come up with something like this, right? Fairly simple. It's like 2.5 times shorter than it was before, and I can read it. And even more than that, the amount of collaborators and amount of messages went 2 times down, right? And you might think, well, this is really excessive, and the controller action will probably be more complicated now. Well, in true, it gets really simple, right? It gets simpler. Now, there is a fair comment that you might say that we are actually pushing all this complexity outside of the controller, and that's a fair point. But where does all this complexity of like getting doctrine goes to? Well, with a rich frameworks like Symfony, you can leverage the dependency injection container. And all this like chain of calls to doctrine to repository could actually go to the doctrine. And then this complex call to get actual projects from the repository could go to the repository itself. So instead of like pushing all the responsibilities into one single method inside your controller, you're spreading them out across the system. And that means every single test in your system is medium level size, right? So the idea is you will have a lot of these tests, but you will never have tests like I had before. right? Second example, a basket checkout. So we have a very simple basket here. So you can add products to the basket, and then basket has this method called checkout to which you pass order processor, which presumably processes orders. So you create a total price, and then you iterate over all the items in the basket. You calculate total price by adding the price of the item, and you add new item to the processor, right? Then at the end, you create a new payment, which is a cash payment, from the price that you calculated, and you set a payment on the processor. And you ask processor to pay, right? That's it. So the test for this guy, if you did test-driven development with mocks, will look something like this. No problems, very simple, very concise. You can read it very easily, and it defines what it does extremely well. Well, that is until you have new requirement. And the new requirement you could imagine could be, well, we deal with cash now, but what if we want to accept credit cards? And now it becomes a little bit more complicated because suddenly we need to duplicate this test, and we need to have two of them, right? One to test checkout with cash, one test checkout with credit card. And the way you will probably implement it, or one of the ways you will implement it, is you will add this additional flag to basket. So this is like credit, this is a cash basket, this is a credit basket, right? And then you check that the right kind of payment was used to set payment, right? Now the problem with this approach is, what happens if you want to add PayPal? You will need to duplicate this thing, maybe introduce the third flag or update this flag to something else, right? So this problem where you will have symmetry in your tests actually illustrates the open-close principle violation, which is another design principle. So open-close principle states that the software entities, including classes, modules, functions, should be open for extension but closed for modification. What does it mean? It means every time you want to add new payment method, like PayPal, you should be able to do this without actually changing your basket. So how would you achieve this? Well, let's go back and refactor our tests in order to be really concise, really short, be a single test, but describe this complex behavior that we want to introduce now. Test checkout with payment method. So we introduce new object, new instance of object, which is payment method, right? And we say payment method accepts payment with this price, will return new instance of payment. So payment method is now responsible to create specific type of payments, right? So you will have PayPal payment method, you will have credit card payment method, and you will have one single interface, which is payment method, with one single method which is accepts payments with price argument that will return new payment instance. So this big line of code, these two tests, or maybe even three tests, become one very simplistic test case, which tests all the edge cases, right? And the actual code will look like this, right? The key point there is we added another argument to our method, which is a payment method. And when we want to create new payment, we just say method, accept payment, pass a price, and this returns our new payment. It could be PayPal payment, it could be credit card payment, it could be any other futuristic payment like Apple Pay, right? You don't care. And every time you want to introduce new payment method, you just need to implement this payment method interface, implement new payment, and that's it. Basket doesn't change, right? The third example, a browser emulation. So I was working for some time on the browser emulation library called Mink. So this example is a very simplified version of the code base. So the way browser emulation works is you have this browser which can do things, which can simulate actual browser behavior, like Firefox or Chrome. And the way it does this is like it has this method goTo, and it accepts browser driver, which is implementation of particular driver, which could be headless browser driver, like Gut, Guzzle, or it could be like Firefox or Selenium or whatnot. And then there is a method goTo, which puts the driver first, and then visits specific URL, right? So in addition to browser class, which is a high-level API, we also have browser driver interface with two methods, boot and visit. And we have two implementations of this interface. We have Selenium driver, which on boot starts the browser, and on visit, just you calls visit URL on Selenium. And we also have Guzzle driver implementation, which visits URL when you ask it to, and it does nothing on boot. Right? It's because Guzzle is actually headless. You don't need to start it. You don't need to boot it like you need to boot Selenium or Firefox. You actually just can visit URLs in a stateless mode. You don't need to boot this guy. So you might want to describe this thing in a very simple form, right? So let's say we're testing like headless browser, like there will be Guzzle driver here. It's a typo. So let's say we prophesize this browser driver. We push it to the browser. We call browser go to URL, and then we call get prophecy check predictions. So check that calls were been made, right? So this thing in prophecy will throw an exception, right? And the reason why it throws an exception is because you are actually expecting one call to be made to driver, but it also calls boot. So your browser implementation also calls boot every time you try to visit URL, and you're not expecting this to happen. So when you're trying to call some methods that you don't expect to happen, this usually shows the problem which is in software engineering called refused bequest. So you can read on refused bequest in Refactoring book by Martin Fowler. So the idea of refused bequest is you are forced to implement methods that you don't really need, and by implementing those methods that you don't really need in this form, actually forces you to remove compatibility between drivers, right? So what happens if we start developing an application using those browsers and different drivers, and we start from using Guzzle driver, right? And we call this like Guzzle open URL directly multiple times, but then at some point we decide to switch to another driver, switch to Selenium. And then we try to visit URL, try to visit, but it doesn't. It just throws a fatal error because we didn't start Selenium. So in this case, our drivers stopped being interchangeable, right? Selenium driver requires you to call boot before you can visit any URLs, whereas Guzzle driver doesn't. And the way to avoid this is you need to add this thing into your Guzzle driver. You need to simulate in your Guzzle driver behavior Selenium driver. When you do this, it is called Liskov substitution principle violation. So Liskov substitution principle states that you need to be able to replace objects of the same type interchangeably, right? So you need to be able to replace Guzzle driver with Selenium or Selenium driver with Guzzle whenever you need to, and your system should still work. Whereas if you have implementation of the drivers where boot is empty, that's not what will happen. Now, the problem with this is that every time you will need to add new headless driver, you will need to introduce this mess into each one of them. So suddenly, all your headless drivers know how to boot, even though they don't need to boot. So the way you fix this is you completely separate interfaces, right? You have browser driver, which does need to boot and does need to visit. And you have headless browser driver, which doesn't need to boot. It doesn't even extend this browser driver. And then you have an adapter layer between them, right? So you still have this mess here inside this adapter. But the thing is, this mess is localized to one single class in your system, right? You created this adapter with a little bit of mess inside it, and then you reuse it for every single headless driver. Your browser doesn't know about this mess. Your headless drivers don't know that they've been simulated to boot. And every single part of this mess is localized in one single class. And the reason why we did this is because mocking tools highlighted refused bequest for us. So the first example is ATM screen. So let's say we are implementing this ATM high-level API, right, which kind of talks with the user, asks user for a card, for a credit card, for PIN, asks for account, asks for amount that we need to give him from an ATM, tells user that there's no money, tells that the machine is empty, right? So we might want to create a test for this guy. Test ATM asks for a card and PIN during login. One particular use case. And we mock entire messenger class, but we use only 2 methods of it. Ask for a card, ask for a PIN, right? When this happens, and it's very, very visible when you're writing mocked-based tests, you are basically breaking interface segregation principle, right? You're introducing interface segregation principle violation, which is another software principle. And it states that no client should be forced to depend on methods it does not use. In this particular case, our entire guy, CT-ATM, depends on the entire messenger with 6 different methods, or even 8, even though it actually needs 2. That creates backwards compatibility problems, and it creates maintainability problems later on. Hence, you have interface segregation principle violation. The way you sort it out is very, very simple. You introduce specific interface, login messenger, instead of the complete messenger. And then you spread out your interfaces. You segregate them into smaller chunks, and you still can have your complete messenger which extends all of them. Because yes, in PHP you could have multi-inheritance for interfaces, right? So you can still do things with your messenger, but every single part of your system depends only on the methods, only on the part of the interface that it really needs. The 5th and the last example is an entity repository. So if you use a tool like Doctrine, you might at some point end up with something like this, right? So we have very simple job repository with find job by name method. You pass a name of the job and it returns you a new job. It extends entity repository, which is Doctrine internal entity repository. If you try to mock this guy, if you try to describe it with unit test, you will have things like this, right? Again, the same problem that we described previously. Too many things are happening there. But now there is a different reason. You could try to apply single responsibility principle solution for this, but it wouldn't work because it's naturally dependent on this third-party system. You are using Doctrine. Trying to hide that you're using Doctrine in this particular case would not help you. So the rule here is very, very simple. Do not mock things you do not own. So this particular Doctrine repository that you have, Doctrine job repository, is not the thing that you own. You don't own how Doctrine works, so you don't mock it. You still need to test it, but you don't test it with unit tests, right? So how do we sort it out, this whole thing? We still need to depend on this like repository, and this is a very specific implementation of this repository which depends on the Doctrine. Well, the way you sort it out is you apply dependency inversion principle. So dependency inversion principle is when you introduce a job repository interface with one single method, just an interface, which has nothing to do with the Doctrine. It lives inside your code base. And you introduce specific implementation of this interface, Doctrine job repository, which still can extend from entity repository. So everywhere where you need job repository, you actually depend on the job repository interface. And you mock this job repository interface in your unit tests. And you have only one integration test for this Doctrine job repository. You do not mock Doctrine job repository, you mock this interface. And this thing is not something that you own. You just integrate with the Doctrine, right? So as you might see, there is a big topic on exposing communications. And I think what should be clear to this point is by exposing communications, it becomes really easy to spot some problems in your design, all right? But there is a drawback, as with any practice. And this drawback is we are exposing communications. Hence, we create more communications as a side effect, right? So because you care that much about communications, you will introduce more small objects that talk between each other because you want to expose it. So going with this approach forces you to create more smaller objects inside your system that talk between each other rather than when you'd use state-based approach. Now, the interesting thing with state-based approach, it has its own drawback, which is whenever you try to assert only state, you will need to expose this state. So the simple outcome is by focusing on outcomes of your system. You will need to add getters more than you would usually do. So you will be forced at some point to add getter just because you need to test this state. And the same thing happens with communications. By caring about communications or focusing on communications, you will be forced to create more of those communications, right? The software design and software engineering lives somewhere in between those guys. Important note with mock-based test-driven development. Do not use broken mocking tools, right? PHP unit mocking library gets better, but I personally, and that's my personal opinion, consider it a broken tool. Use mockery, use prophecy, any other mocking library with PHP unit if you want to use PHP unit. Do not fake value objects. So value object is email class or username class. Do not mock them. Do not even try to mock them. Just use them. They are representations of the values. Do not fake collections. Do not mock collections. Just use them. They are simple collections, right? You do not mock arrays. You do not mock collections. Do not fake parts of the objects. So every time you want to mock part of your class that you're actually testing, that's hindsight for single responsibility principle violation. Your object tries to do too many things. It has two-phase syndrome, tries to be two things at the same time. And the most important one, do not use mocks for isolation. Mocks are not for isolation, mocks for design. Mocks for exposing communications in your system so that you can improve it. Every time you use mocks for isolation, you're shooting yourself in the foot. Right? And we have plenty of examples. DHH is one of them. So recap. State-focused TDD is not the only way to do TDD. It's not the best one. It's not the worst one. There's different ways you can approach test-driven development, including acceptance tests, end-to-end tests, and functional tests. Today, I just tried to show you another way which is based on mocks. Messaging is far more important concept of OOP than the state. By focusing on messaging, you expose messaging problems. By exposing messaging problems, you could discover most of the solid principles violations, and that's what we were doing today. I showed you every single of solid principles and how by exposing communications in an underlying system, you can find solid principle violation and improve your underlying system, comply with solid principles. And there is the fifth rule, which is messages define objects' behavior. Messages is what behavior of your objects is about. And this is why mockist approach to TDD, where you expose communications between objects, is part of the BDD, or behavior-driven development. It's just lower-level behavior-driven development. Any questions?
Hi, thank you for your presentation. Could you explain why you consider PHP unit mocks a broken tool?
Right. So there's a couple of reasons. First of all, they kind of push out from you things that you don't really need to care when you're mocking things. It has things like order-based mocks. So you say, this method should be called first, and this method should be called second. And that's, by the way, how they describe this in the documentation. So when you do these things, you actually, indeed, couple yourself to implementation. Every time you try to refactor this method and basically move method calls around, which doesn't change behavior, external behavior of the object, your PHP unit test doubles usually break. And the reason why they broke is not because you changed behavior. They didn't highlight that you did something wrong. You basically changed the internal structure of the method. And tests should never break in this case. Another example, and this is something that I heard, I didn't use PHP unit for quite some time, but I heard this feedback from people where in PHP unit it's possible to mock class or an interface and call non-existent method on it, and by default it will do nothing. So it doesn't highlight that you're trying to call non-existent method on the interface. And there's a lot of really small things that are around this where they're not necessarily make your life worse, but they don't help you much either with the mockist approach. PHP, like essentially, I think, looking at PHP unit mocks right now, it seems to me that they were being created as a way to isolate things, right? That's their primary focus. Their focus is to help you isolate from third-party systems. Whereas, as I described, the good mocking library should be focused on design. Okay, does it answer? Does it? Any more questions?
Not a question, but a reply.
Mm-hmm.
So I created the PHP unit mocking code mostly like almost 10 years ago.
Okay.
And first off, I totally agree with you, it's broken.
Mm-hmm.
Unfortunately, I'm not allowed to change it.
Yeah, I know.
And more, I suggest to people to use something like prophecy or mockery. Personally,
yeah.
I would prefer a prophecy instead of mockery.
Mm-hmm.
But there's no way to fix all the things that are broken with PHP unit's mock object implementation without breaking millions of tests that are out there.
Yeah. I mean, don't get me wrong. It's not bashing of the tool or anything. It's just like I'm saying it's broken. And I know that like it's impossible to fix it at this point because of the whole backwards compatibility changes that you will need to introduce in the process. So it is broken at this moment, but it's really extremely hard to fix it. So yeah, it's better to just use different tools. And it's not like PHP unit forces you to use PHP unit mocks.
Exactly. I think we need to get better to make it pluggable at some point, but yeah.
Yeah, thank you very much.
And I did not misunderstand you as bashing, so.
Okay, cool. Good.
I get that a lot, but this was not bashing. Thank you.
Okay, thank you. Okay.
Thank you.